Those of you who watch my channel on a regular basis know that I cover Oumuamua with a great degree of frequency. One of the reasons, of course, is that the topic is so popular. The last video I released on Oumuamua racked up over 200,000 views. Clearly, this has a very large audience. But on the other side of the equation, I feel that this subject needs to be talked about in the media as often as possible because the mainstream media has essentially tried to bury it. Oumuamua has had so many different natural explanations put forward by the mainstream scientific community, only to be shot down. First, it was a block of solid hydrogen. Then it was a block of nitrogen. Then it was a comet without a tail, or a so-called dark comet, something we're not even really sure exists. And after all of these explanations have been put forward, only to be shot down, the media and the mainstream scientific community has simply decided to try to forget it, to bury the topic, to never talk about it again, because the only reasonable explanation, the only explanation that fits all of the facts, is that Oumuamua was an artificial object created by an alien civilization. And the reason that this particular UFO, if you will, is so much more significant than any other UFOs that have been spotted throughout history is the fact that we have so much data about it. We know so much about this object as opposed to UFOs that have allegedly been tracked on radar, allegedly seen by hundreds of witnesses, allegedly photographed, but really not enough evidence to prove that these UFOs were ever even really there, especially given the fact that the military never lets anybody study the actual radar data. This is entirely different. The best telescopes on the planet were trained on this object for months. They saw everything that it did, and that's why it's such a unique and unusual object, something unlike anything we have ever seen in astronomy. And with every new discovery about Oumuamua, or anything related to Oumuamua's appearance in our solar system, it becomes increasingly clear that for the first time, we have solid, indisputable proof that an artificial object, the product of an alien civilization, passed through our solar system in 2017. Good afternoon, alien enthusiasts, and welcome to another Angry Alien Bulletin. We are returning to the topic of Oumuamua for one reason, just because it interests me so much, but also because a lot of new information continues to come out from various sources that are, frankly, unwittingly confirming the artificial and alien civilization origin of this mysterious object that passed through our solar system back in 2017. Now, the first of these studies just has to do with the likelihood of Oumuamua being a natural object, the natural object traveling from star to star and just by chance happening across our solar system and happening to pass as close to Earth as it did. The study was undertaken in great details, just determining the orbital trajectory, the time of arrival, that sort of thing, to see just how likely it was that not only did an object like Oumuamua encounter our solar system, but how likely was it that it would pass so close to our planet, to the one planet in our solar system in the Goldilocks zone of this star. And the odds are unbelievably against Oumuamua being a natural object in the face of everything else that we know about this object, all of the things that it did that screams an artificial origin, that absolutely defies the behavior of any natural object that we are familiar with. Well, this study makes it even more certain. So, in the course of this segment, I'm going to be quoting from an article entitled Exploring Oumuamua's Perihelion Date by Adam Hibbard, who is a British physicist and astronomer. And his findings were quite interesting indeed. What he maintained is the only thing that theoretically could be variable about Oumuamua is its arrival time in our solar system, its closest approach to the sun, and its closest approach to our planet. Now, before we get to all of these details, let's briefly cover the strange things that Oumuamua did during its visit to our solar system. For one thing, at the time of encounter, Oumuamua was traveling at a speed and trajectory consistent with what's called the local standard of rest. What that means is it was moving at a speed consistent with the overall rotation of the galaxy. In other words, relative to the stars moving around it, Oumuamua was essentially stationary. This would be very useful as a navigational aid, or perhaps for a probe designed to explore the various stars in the galaxy, because the rotation of the galaxy would bring you into close contact with these stars without having to use any propellant. It serves a number of different useful purposes that again screams artificial origin, because the odds of this happening purely by chance are approximately 500 to 1. Not impossible, but still quite unlikely. In addition to that, Oumuamua was highly reflective. It rotated at a very consistent speed. That in itself is not unusual, but the strangest thing that it did overall was the fact that it began to accelerate as it left our solar system. Accelerated with no visible form of propulsion. And the only object in nature that can do that, at least as far as we know, is a comet. Comets have natural outgassing that can sometimes cause a change in velocity and trajectory. However, when that happens to a comet, its rate of rotation also changes, and Oumuamua's rotation didn't change at all. And in addition to that, while this acceleration was happening, no visible outgassing was detected, even though the best telescopes in the world were trained on this object the whole time. Oumuamua was a comet without a tail, which means it couldn't have been a comet at all, which means it couldn't have been a natural object. No natural object can accelerate without visible outgassing, especially as much acceleration as Oumuamua demonstrated, moving over 100,000 kilometers out of position in the space of just a few weeks. All of that being the case, though, this particular article addresses the fact that Oumuamua passed so close to the Earth, apparently purely by chance. So let's go ahead and quote from the article. What happens if we keep all of Oumuamua's parameters fixed? In other words, the orbit, the trajectory through the solar system, and just change the perihelion date and time. Perihelion, of course, being the closest approach to the sun. I did this for a range of perihelion times spread throughout the year 2017 and plotted out the consequent effect it had on the perigee distance, the closest approach of Oumuamua to Earth, and we get the following. As you can see, apparently purely by chance, Oumuamua came ridiculously close to the Earth when if it had come at any other time, it would have passed at a much greater distance to our planet than it actually did. The article continues, quote, "We find that the true perihelion of Oumuamua was such that its subsequent perigee, 0.16 astronomical units, was nearly as low as it could possibly have been to the Earth. Had the perihelion fallen on the 19th of September, 10 days later, then the perigee would have been even lower at 0.095 AU. Let's now suppose, hypothetically, that Oumuamua chose its perihelion date deliberately to be the 9th of September for some reason. What would be that reason? The following plot provides the same data as above, but also provides an additional dotted curve with a second vertical axis on the right-hand side, indicating the Sun-Earth angle. In other words, the angle subtended at the Earth between the Sun and Oumuamua. If this Sun-Earth angle is less than than 90 degrees, then Oumuamua would reach perigee on the sunward-facing side of Earth. If, however, it is greater than 90 degrees, then it would be on the night side of Earth and will potentially be observable by telescopes. Furthermore, the larger this Sun-Earth angle, the more conducive Oumuamua will be to observation by Earth-based telescopes. What we find is that Oumuamua's perihelion date was such that when perigee was achieved, it reached almost the largest possible Sun-Earth angle. The optimal angle for this is actually on a perihelion date of the 9th and 10th of September, maximizing its chance of observation. What are the odds of all of this happening purely by chance? Well, again, the odds are approximately 500 to 1. So what are the odds of a natural object just happening to be traveling at the local standard of rest, which is such a useful thing, and just happening to pass so close to our planet in such a way that it could be easily spotted, which, by the way, it was? What are the odds of all of that happening by chance? Well, the odds increase to 250,000 to 1. But if Oumuamua were artificial and was able to decelerate in such a way that it would make such a close approach to Earth, and we saw it accelerate, so why couldn't it decelerate? Well, then that explains its behavior perfectly. But again, if it's a natural object, boy, it's defying some serious odds. But if you think those are extraordinary odds, I'm just getting started. And so now we need to move on to the second scientific discovery, the second astronomical observation that was originally made by Chinese astronomers. And this is not something in regard to Oumuamua, but rather in regard to another topic I like to talk about on this channel, hypervelocity stars. And this was very interesting indeed, because for a long time now, astronomers have claimed, the mainstream scientific community has claimed, that hypervelocity stars traveling so fast that they can escape the gravitational influence of the Milky Way, the only way that they could possibly be propelled to these types of velocities is to pass into close proximity of a supermassive black hole, like Sagittarius A at the center of our galaxy. But of course, there are other hypervelocity stars that have been discovered that aren't coming from that area at all. So a few others were discovered, apparently perhaps coming from the large Magellanic Cloud that orbits our galaxy in close proximity, and that too must have some kind of supermassive black hole, they reasoned, even though there's no other evidence to indicate that there is actually a black hole there. But they concluded that there must be, because that's the only reason that a hypervelocity star could be traveling that fast and coming from that point of origin. But then other stars have been discovered that aren't coming from either the Large Magellanic Cloud or from the center of the galaxy, but rather coming from a globular cluster. How do you explain this? What sort of supermassive black hole might lie at the center of a few thousand stars, or perhaps even a few million stars? How could something so powerful possibly exist there? Well, it's because the astronomers are now claiming that there's a new class of black hole, an intermediate supermassive black hole, something along those lines. That sort of thing must exist, even though we found no other evidence to prove their existence, only these hypervelocity stars. There must be something that massive, but still not quite as massive as the black hole at the center of the Large Magellanic Cloud, not quite as massive as Sagittarius A, but still massive enough to propel a star to these types of insane velocities. But you wouldn't believe how close these stars need to come to this intermediate size supermassive black hole in order to make all of this happen. And so just for fun, I decided to crunch the numbers to see just how likely an event like this might be. And the results were utterly staggering. And believe it or not, the results also directly coincide with the likelihood of an object like Oumuamua being natural in origin. Black holes come in a range of sizes. Stellar mass black holes form from the collapse of massive stars, typically weighing between 5 and 100 times the mass of our Sun, and are scattered throughout galaxies. At the other extreme are the supermassive black holes that lurk at the center of most galaxies, including our own Milky Way. In stark contrast with stellar mass black holes, the masses of supermassive black holes range from millions to billions of times that of the Sun. They shape galactic evolution and can power quasars when actively feeding. But between the two is another, rather more elusive category known as intermediate mass black holes, or IMBHs, which weigh between 100 and 100,000 solar masses. Scientists have struggled to definitively identify the latter category, although evidence of the existence is mounting from observations of unusual stellar motions, gravity wave detections, and extremely luminous X-ray sources. Understanding these IMBHs could reveal crucial insights about how stellar mass black holes grow into supermassive ones and fill an important gap in our knowledge. Current theories suggest that globular clusters may harbor IMBHs thanks to their extremely dense stellar environments. These IMBHs could form either rapidly through stellar mergers, creating massive stars that collapse, or slowly via successive mergers of stellar mass black holes. Hubble Space Telescope observations of globular cluster M15 suggested that it might contain an IMBH of 1,700 to 3,200 solar masses based on velocity dispersion measurements. However, this idea remains controversial because the measurements were taken at a distance where thousands of compact stars could influence the results without necessarily indicating a black hole. In other words, there's no solid proof for the existence of this black hole aside from one interesting detail, and that is the star J0731 plus 3717. I guess, again, you need to get used to these sorts of things if you're going to study astronomy. A recent study led by Associate Professor Yang Huang from the University of the Chinese Academy of Sciences has identified a promising method for detecting these black holes by tracking high-velocity stars ejected from globular clusters. The extreme velocity of this star, approximately 550 kilometers per second, suggests the star was accelerated by the gravitational slingshot effect, also known as a Hill's mechanism, from an interaction with an IMBH at M15 center. The team suggests that a tight binary system must have passed within one astronomical unit of an IMBH with a mass of several thousand solar masses. Let me say that again. Must have passed within one astronomical unit of an IMBH with a mass of several thousand solar masses. Let's see exactly how likely an event like that could possibly be. Because keep in mind, space is huge. The space between stars, even in tightly compacted globular clusters, is utterly enormous. What are the chances of an object by pure happenstance passing within one astronomical unit, especially if we're talking about a star here, passing that close to this supposed black hole? Well, with the help of AI, I decided to see just how likely it was that something like this could happen within our own solar system. What is the probability of a randomly directed object in the galaxy passing within one astronomical unit of our Sun? What are the givens in this problem? Well, the radius of the Sun's sphere of influence being 1 astronomical unit, the radius of the Milky Way galaxy being 5 times 10 to the 20th power meters, and then 1 astronomical unit being 1.496 times 10 to the 11th power meters. So let's go ahead and take this problem step by step. First, the area of a circle as given by area is equal, of course, to pi r squared. The radius being 1 astronomical unit, which is 1.496 times 10 to the 11th power meters. Therefore, the area of the Sun's sphere of influence is pi times 1.496 times 10 to the 11th power meters squared, or 7.03 times 10 to the 22nd power meters squared. Pretty damned impressive, but let's calculate just how big the Milky Way is. The Milky Way's area is pi times 5 times 10 to the 20th power meters squared, or 7.85 times 10 to the 41st power meters squared. So what is the probability of an object passing this close to our sun? Well, you take the probability as being the area of the sun divided by the area of the galaxy, or 7.03 times 10 to the 22nd power divided by 7.85 times 10 to the 41st power, and you come up with the probability of a randomly directed object passing within 1 astronomical unit of the sun is approximately 8.95 times 10 to the negative 20th power. Now, of course, this problem is further modified by the number of stars in the region of space where the sun is located. Let's assume that that's 10 billion stars or so. So we're talking about reducing it by quite a number of orders of magnitude. But even if you do that, you are still looking at a number of well over 1 trillion to 1. Now let's go ahead and talk about M15's core. That is a little bit different because its density is approximately 1 million times more dense than the area around the sun. But even if you look at those kinds of statistics with that kind of density, you are still looking at odds in the billions to 1 of something like this happening purely by chance, even in a dense area like M15. The distances between stars are just too enormous. And if even this were true, it would suggest that a dense core like M15 would also have quite a number of stars passing a lot further away from this supposed black hole, say 5 astronomical units or 10 astronomical units. This must be happening on a very regular basis. And keep in mind, the escape velocity of a globular cluster is substantially smaller than the escape velocity of the Milky Way galaxy's core. That being the case, then, this globular cluster should leave a trail of hypervelocity stars behind it, not traveling as fast as this particular star, maybe 100 kilometers per second or 200, and yet it's not doing that. It only has this one hypervelocity star, which, by the way, has a velocity that's very consistent with other hypervelocity stars that we have detected throughout the galaxy that have supposedly been propelled by a supermassive black hole much heavier than the one that supposedly exists at the center of the M15 globular cluster. And keep in mind one other detail. The Milky Way's core has a density of 10 million stars per cubic parsec, whereas M15's core has a density of only 4 million stars per cubic parsec. And yet we have no evidence to suggest that a star has passed within 1 astronomical unit of the Milky Way's supermassive black hole, which, by the way, would have created an incredible velocity star, far faster than any stars we have detected thus far, and yet there's no evidence that anything like that has ever occurred, even though the stars packed around the Milky Way's supermassive black hole are more than twice as dense as the density of M15's core. All that being the case, then, in my opinion, this makes a strong case for at least some hypervelocity stars being the product of massive stellar engines built by extraterrestrial civilizations who are trying to move their solar systems from one region to another, or perhaps from one galaxy to another. But instead of revisiting that concept, but if you're interested in it, I've got links at the end of this video. Instead, let's go ahead and return to Oumuamua. If the odds of a star or something else passing that close to the sun, 1 astronomical unit, are that remote, what are the odds of Oumuamua passing less than 0.2 astronomical units of Earth purely by chance, on top of all of the other odds that we've been talking about up to this point? Now, granted, it has been supposed that there's a substantial amount of these objects in interstellar space, but really, how many of them? Because Oumuamua is not a comet, it appears to be an asteroid of some kind, so unlike 2I Borisov, which is a legitimate interstellar comet that passed through our solar system a couple of years after Oumuamua did, and by the way, passed the Earth at more than 10 times the distance that Oumuamua passed from our planet, well, this seems like a more legitimate natural object, obviously, because it's a comet with a tail. It passed through the solar system without paying the Earth so much as a buy your leave, because why would a comet really care where the Earth was? All of that makes perfect sense. Whereas the object that bore no resemblance to a comet without a tail, a comet that accelerated without any visible forms of propulsion, a comet that passed within less than 0.2 astronomical units of the Earth purely by random, what are the odds of that? And now let's go ahead and jack these odds up even more, because in the same year that Oumuamua made its close approach to our planet, confounding scientists across the globe, another interstellar object, much smaller, a spherical object of some kind, entered our atmosphere at a similar velocity and impacted off the coast of Portugal. What are the chances of two interstellar objects, one of which passing ridiculously close to our planet and another one impacting our planet, all in the same year on top of all of the other improbable things that have happened with this particular object? What are the odds then? Well, according to the artificial intelligence that I asked the same question to, the odds are so close to zero as we can discount the possibility of it ever occurring. And so if you remove all the prejudices of the mainstream scientific community from this study, the conclusion is obvious. Oumuamua's visit to our solar system was not a random thing, but happened by design. So in the face of all of this evidence, in the face of all of these staggering odds, how can astronomers, how can the mainstream scientific community continue to cling to the theories that they maintain so stubbornly, even though the odds of what they are describing are so astronomically unlikely and also are not supported by any of the other evidence? Why did they continue to cling to these crazy theories? Well, because the only other option is to pursue an artificial origin, to pursue the idea that there's not only advanced alien civilizations in the galaxy, there may be incredibly advanced alien civilizations, not only capable of dispatching craft like Oumuamua, but also capable of moving stars from place to place. Rather than exploring this possibility, examining these stars and these objects for possible artificial origin or some sort of anomaly that would scream technosignature, they ignore these things because they know that if they propose these sorts of alternatives, if they write a paper that suggests that any of these things might have an artificial origin, an alien origin, so to speak, their careers are essentially done. It is as narrow-minded as the Catholic Church was in the time of Galileo. These people that refused to look through his telescope because what they would see there would fly in the face of everything they knew to be true. Not what they believed to be true, but what they knew in their hearts to be true. And so instead of exploring an alternative that would debunk these beliefs, that would challenge or overturn these beliefs, they instead refused to look through the telescope, just as scientists today refuse to explore these possibilities. Thank you very much for watching. Please don't forget to like and subscribe, and also please consider supporting this channel on Patreon and PayPal. It's the only way I can keep this whole thing running. As I've said a number of times, right now Google is just cutting back on their ad revenues that they pay to creators, to the point where we just can't make a living unless we have support from other sources, and you guys get benefits as well. I have a expanding library of exclusive content for Patreon supporters. All the details in the description. So until next time, stay angry about space.